thing I want to say is I have made a list of all my students with D's or F's. And I want to give you a 24-hour notice that tomorrow morning I will be emailing home the parents of all my students who still have D's and F's. A lot of you are really close to being out of that range. So I'm giving you 24 hours notice to get some assignments turned in so that you don't get that email home. Because what the email home will say is your student is at risk of failing this class and having to retake it. By the way, we have summer school options. So if you don't want to be someone who benefits from those summer school options, please make sure that you do some of your missing assignments. I am accepting work until June 18th, which is very kind and generous, and I don't think most of your teachers are giving you that long. However, I don't want you to procrastinate, run out of time, and then fail to get credit for this class. So if you have a D or an F, it's because you have missing assignments, and you can still do those assignments, and I'm going to say so individually to your parents tomorrow, unless you get your grade up to a C or higher today. So even though we don't have study hall in the schedule today, it is an early release. You do technically have time. So I need you to make sure that you are doing your missing assignments. Questions about that? That applies to my people at home too. I got some D's and F's at home. I got some D's and F's in this classroom. All right. So today we are learning about how to write and recognize nuclear equations. And so I want you to copy, we're going to be doing example problems for our learning today. And we're going to be filling in the blanks. So we're writing this equation down. Jackson, do you need paper? You're going to need paper for today. Everything we're doing is much easier handwritten. I've got some if you need it. All right. So taking a look at the equation that you've written down, the way this works, just like when we balanced equations, is the arrow is like the equal sign. Jackson Adams, are you good? Are you wearing a mask? Are you wearing a mask? So the arrow is like an equal sign, and so we need the numbers on each side of the arrow to add up to what's on the other side of the equal sign. And so here we've got 90 and 2 on the bottom. So what number do we put on the bottom on this side? 92. And we've got 234 and 4 on that side. So what do those add up to? 238. And then we look at our periodic table. We say what element has an atomic number of 92? And the answer is uranium. So we can fill in those blanks relatively easily. The other thing I want you to do is I want you to identify what type of reaction it is. So I always say start by looking for an alpha particle or a beta particle. In this problem, do you see an alpha particle or a beta particle? Well, what is an alpha particle? It's a helium nuclei. Do you see a helium? That's alpha decay. Let's try another problem. So remember the arrow is the equal sign. Try to fill in those numbers yourself. Jackson Adams, will you move your backpack so I can see that you have paper out and that you are writing? Will you move your backpack and then get some paper and start writing? Thanks. So we've got a 16 on the right of the arrow. So the two numbers on the left of the arrow need to add to 16. And so 5 plus what equals 16? It's not an S, it's a 5. I know, my 5s do look like S's. All right, 5 plus what equals 16? An 11. And then we need the numbers on top to match as well. This side adds up to 32. So 11 plus blank equals 32. 21. And then we look at the element on the periodic table that has an atomic number of 11, and that would be sodium. Now we need to identify what type of nuclear reaction it is. The first thing I always say to myself is there an alpha or a beta particle on the right side? Do you see an alpha particle? Do you see a helium? No. Do you see a beta particle, which is either a positive or a negative electron? You can have beta decay and positron beta decay, which is a type of beta decay. Do you see anything that has a little e for an electron on the right side? No. So that means we're left with either fission or fusion. And remember, we learned that fusion is when two elements slam together and make something bigger. Fission is when a bigger element breaks into smaller ones. So here we have two elements that are making something bigger. So what type of reaction is this? Fusion. All right, I want everybody to copy down this next problem. We're going to try it together. So write it down. Add it up so the numbers on top are equal, the numbers on bottom are equal. Okay, so remember the arrow is our equal sign. So the numbers on one side of the equal sign have to add up to match what's on the other side of the equal sign. So we have 53 on this side, we have 54 and blank. 54 plus what equals 53? Negative 1. And then we have 131 on this side. 131 plus blank equals 131. 0. So what is negative 1 and has a mass of 0? An electron is negative 1 with a mass of 0. So now we want to identify the type of reaction. Does this have an alpha or a beta particle on this side? Yeah, it has a beta particle, right? And so we've identified it as beta decay. How is this feeling? Is this doable? We're going to do a whole practice worksheet in a minute. We're going to do another problem together first. All right. 235. Sorry, my S's, my 5s look like S's. 235 over 94. Plutonium plus a neutron makes 85 over 36 plus blank All right. So this has multiple things on both sides of the arrow. Remember, the arrow is the equal sign. You can add up multiple things and make both sides of the arrow still equal to each other. So here we have 94 plus 0 on the bottom. And so this whole side adds up to 94. So we need to get this whole side to add up to 94. We've got 0 here, and we have 36 here. So what number goes on the bottom here? 36 plus what equals 94? 58. And then on top, I got 148. Anyone else get a different number other than that? Did you see this 3 here? So this is 85, and this is 3 neutrons. So it's not just one. It's actually, put your mask on, please, Grady. It's actually 3, because 85 plus 3 is 88, and 88, anyway, it adds up to 148. I'm having a brain fart. Oh yeah, so this is 235 plus 1. This is 236. And so this side has to add up to 236. So it's 85 plus 148 plus the 3, because there were 3 neutrons, equals 236. This is like kind of a harder one. Now, on this one, do we see an alpha? Oh wait, what element is this? We look on the periodic table. We look at element 58, that is Ce. And then we have to identify this reaction. Do we see an alpha particle or a beta particle? Do you see any heliums or any electrons of any type, positive or negative? No. So then it's either fission or fusion. Remember, fusion makes a bigger element. Fission makes smaller elements. We got an element of 94. We got elements with 36 and 58. So this must be fission. Okay. So what I have for you guys today is a worksheet, and it's posted on the Zoom and other important links for my students at home. But before you go to it, I want to point something out on this worksheet for everybody. This worksheet looks very similar to the types of problems we just did. I want you filling in the blanks, and then I want you to label alpha, beta, fission, or fusion. We're going to have a homework quiz on this tomorrow, so we want to make sure we're practicing. The one thing that's different on this worksheet than what I did is I always gave you the bottom numbers. See how this doesn't give you the bottom number? That's because it doesn't have to, because you can find that information on the periodic table. You find potassium on your periodic table, its atomic number is 19. It would help you if you write that down, because then you know what number you're adding to. So when I do this worksheet, the very first thing I do is I fill in any bottom numbers that are missing. So I'd look up plutonium and I'd fill in that bottom number so that I can make sure things add up appropriately. Okay, so then you're filling in the blanks and you're labeling them as alpha, beta, fission, or fusion. There is one down here, number 8, that has a positive electron. It's called a positron. That one is beta as well. If it looks like a little e, it's going to be beta either way. Okay, so the worksheet's up here for my in-person people. It's on the Zoom and other important links for my people at home, and the answer key is available for everybody on the Zoom and other important links. So we're going to work on this worksheet today. The answers are available for you to check your work, and then we're going to take a homework quiz on this tomorrow. So let me know if you have any questions. My Zoomers, you're welcome to stick around if you'd like, or you can go just work on this independently, but do make sure you practice before class tomorrow.